Hi everyone, this is Mehsan and welcome to my channel. Today we are going to discuss a very small concept for Iit-Jee and Neet. And if you are a serious aspirant, you can write in my email regarding if you require any help for Iit-Jee or Neet. Let's discuss. So see here, two compound is there and they are GI of each other. What is meant by GI? Geometrical isomer. They are isomer of each other. What is this? Malic acid. This is fumaric acid. Malic acid IUPAC name but 2 in 1,4 cis but 2 in 1,4 dioic acid, and this is trans but 2 in 1,4 dioic acid. Okay, now you can see here I have given 2 pKa value for each of the molecule. Why? Because they have 2 carboxylic acid, as simple as that. Yes, they have 2 carboxylic acid, or for that you will get 2 pKa value, 2 acidity. Now if they are simply asking in exam which one is more acidic, generally they are talking about the first pKa. Okay, don't get confused. If they are asking simply malic acid, fumaric acid, which is more acidic, you go for first pKa. Whoever is lesser, you go for that malic acid. If they ask particularly that pKa 2 for malic acid or fumaric acid, which one is more or less, they are particularly mentioned about pKa 2. At that time, you have to go for fumaric acid. Now you should understand that why it is happening. Why first one is this one, but second one pKa is that fumaric acid is the winner. Now simply if you are talking about the acidity, what is mean by acidity? That acidic hydrogen will be there. We need to remove that hydrogen in the form of proton. Once you remove in the form of proton, we are getting conjugate base, and based on the stability of that conjugate base, we can tell which compound is more acidic, which compound is less acidic. Suppose we are taking here one compound, cyclohexane OH. Yes, then another compound, let's take benzene OH. If you see here also hydrogen is attached with oxygen, here also hydrogen is attached with oxygen. They are attached with same atom. But once I remove from here hydrogen, I got O minus, and once I remove from here hydrogen, what I will get? I will get O minus, but benzene ring. This is called phenoxide. This is cyclohexane, oxygen minus. Yes. Now the stability about this compound or this compound, that we need to compare, and we need to find out which one is more acidic. So phenoxide has the ability to resonance, since because of that it is more stable. So this we can give the overall conclusion that this phenol is more acidic than this cyclohexane 1 Okay, so that kind of thing only. So only you have to see the stability after remove the proton. Now same thing let's do from here. Let's remove one proton from here. I got negative charge. I will remove one proton from here. I will get negative charge. Okay, but once I remove one proton from cis form, I will get the hydrogen bonding with this hydrogen. Yes, hydrogen bonding is possible. Oh my god, let's write like this. I will get the hydrogen bonding. So it is stable due to the resonance, and same time hydrogen bonding also possible here. But here only resonance is possible. There is no hydrogen bonding. Since hydrogen bonding is coming one extra factor here, so this pKa is lesser compared to the other one. This in conjugate base form, this one is more stable than the other one. Now let's go for pKa2. Okay, for pKa2 we need to remove the another proton which is left. Okay, once I remove this proton, first of all it is under hydrogen bonding, so little difficulty I will get to remove, but hydrogen bond is not very strong one, we can remove. We will get this one, and here I have removed this one. I will get O minus. Now you see one thing, that here also carboxylate, here also carboxylate, they will do the resonance, and this one and this one, since both have the negative charge, they will do the repulsion also. Okay, due to field effect, they will do some repulsion to each other, instability will create. Okay, but here you can see both will do the resonance, and they are stable with them, and there is no steric effect. They are far away from each other. So here you can say pKa2, this is 6.5, but this is 4.5. You understand? So pKa2, this fumaric acid is more acidic than the. For malic acid, if they are asking pKa1, malic acid is the winner over fumaric acid. If they are asking about pKa2, then fumaric acid is the winner over malic acid. Okay. And one more thing I want to tell you, whenever you are learning something in organic chemistry or in overall chemistry, inorganic chemistry mainly, whatever you got, based on that, don't try to make any statement. Okay, what I mean that don't make any generalized statement that cis carboxylic acid is more, or cis acid is more acidic than the trans. There is nothing like that. Okay, In this case particularly, if they are simply acidity, you can go for malic acid. If they particularly mention about pKa1 or pKa2, then based on this value only you can go. Okay, now I am telling here cis form was the winner for pKa1, but if I go for suppose this type of molecule FCC11COOH, hydrogen, this is cis form, right? Let's write the trans form. Here hydrogen, here fluorine. Now you say which one will be more acidic, whether cis will be more acidic or trans one. Now you have, here only pKa1 only one acidic hydrogen. Okay, now here you can see that this hydrogen is already can make the hydrogen bond with this fluorine. Okay, so it will be more difficult to remove the first, whatever proton is left, that one only it is difficult to remove compared to the other one. But here who is the winner? Here trans is the winner. Okay, but here who is the winner? Cis is the winner. So don't make any generalized statement based on the compound, based on all this effect, what hydrogen bonding where possible, where resonance possible, where extended conjugation possible, where this field effect possible, all this, with respect to all this only you can go for your final result. Okay, and if you know the pKa value for individual any molecule, then that is very good, but that is not possible practically to know any random molecule pKa. Hope you understand what I am trying to say. Thank you for watching and do share with your friend. Thank you.